inputs and costs. So that's what Chapter 11 is about. Now, as a producer, you have two main kinds of inputs. You have inputs that are like capital, big things like buildings, vehicles. Those are what we call fixed inputs, because those big things like buildings, you can't change them very easily, or it takes a really long time to change them anyway. And then the other kinds of inputs that are easier to change, like how many people you've got working for you, how much paper you're using, how much tomato sauce you're using, whatever it is. Those are things that you can change pretty easily, and so those are called variable inputs. Okay, so for SFU, for example, the building is obviously fixed. And other things as well, like the number of chairs even, right? They can change the number of chairs, but they can't do that by tomorrow, right? It's something that's fixed sort of for the short term. So, but then I'm a variable input, because they can either hire me for the semester or not hire me for the semester, right? It's pretty easy for them to change that. All right, so first is the fixed inputs, and so those are things that are not easily changed. And then variable is the opposite, things that can change fairly easily. So the variable inputs, the quantity can be changed in the short run. Okay, so then the next two vocabularies there are short run and long run. So these time periods refer to how long it would take you to be able to change your fixed inputs if you wanted to. So for SFU, if they wanted a bigger building here, well, that would take a long time, right? To go through all the, the applications to make it bigger and to do all the changes, right? And that would probably be several years for them to change the size of the building. And if you were, say, a farmer, you'd have to change the amount of land that you could get, and that could take some time, depending if there's land available for you to buy or rent or whatever. Other things are maybe a little bit easier to change, like, say, the number of vehicles that you're using or computer systems. So the short run is just defined as not enough time to change your fixed inputs. And then the long run is enough time to change your fixed inputs. But how long that is really depends on your business and what kind of fixed inputs that you have. Right? So for example, if you're a farmer growing tomatoes versus a farmer growing apples, there's going to be a big difference, because for tomatoes you need tomato plants, and tomato plants only take a couple months to grow. But if you want apples, you need apple trees, and apple trees take at least 5 or 10 years before they're big enough to actually be growing apples, right? So for an apple farmer, the long run is going to be a lot longer than, say, for a tomato farmer, right? So it really just depends on what you're producing and what sort of capital you need. Okay, so let's see. So long run, that is enough time to change everything. So the time period over which all inputs can change. And then in the short run, it's not enough time to change everything. So that in the short run, there's at least one thing that is then fixed, because you don't have enough time to change it. Okay, so this is important when we talk about producers making decisions, because as a producer, you know, of course, that when the price changes, producers would like to change the quantity that they are producing and selling. But it's not always easy to do that, right? If the price goes up, and let's say tuition goes up and SFU wants to offer more classes, well, they can't because they've got all of the classrooms that they've got are filled, they're being used. And so in order to offer more classes, they'd have to build more building space and more classroom space. And so then they couldn't make any changes in the short run. They'd have to wait several years before they could make changes in the number of classes that they offer. Whereas if you're a tomato farmer, then it's a little bit easier to do that, make changes. Okay, so first, before we talk about costs, we're going to talk about production and productivity, because of course your costs depend on your productivity. Okay, so we've got two functions here to talk about. First is called the total product curve. So the total product is just another word for output. So this curve is going to show how much you're able to produce, so how much output you're able to produce, given how much inputs you're using. And the input that we'll talk about mostly here is going to be labor. So depending on how many workers you have, what is your output? And so this graph will show that relationship. Okay, so it'll show the relationship between total output and the quantity of the variable input, which again will usually be labor that we talk about. So given a certain quantity of the fixed input, so what that means is, say if you're a farmer, you've got a certain amount of land and you want to produce more tomatoes, well, you can hire more people to help you produce more tomatoes, and the more people that you hire to help you, the more tomatoes you will be able to produce. But the amount of land that you have is fixed. And so that's going to then have an impact on the productivity, because you can hire more and more people to work on your one piece of land, but there's a limit to how much you can actually produce on one piece of land. And so as you hire more and more workers, the amount of extra output they will help you create is then going to diminish. Okay, and so that is the next one then, is marginal product. So marginal product is when you hire one more worker, how much extra output do they produce for you? And so that will diminish, because if you have a fixed piece of land, you can hire more and more workers, but you know they're working with the same piece of land. And so as you hire more and more workers, it will help you increase your output, but that increase in output will diminish. All right, so the formula here, it's different from the other marginal formulas that we've done, because all the other marginal formulas for like marginal cost, marginal benefit, marginal revenue, they all have delta Q on the bottom. But now what we're measuring is delta Q and how that relates to an increase in your labor force. Okay, so MPL, marginal product of labor. All right, so here we have a table showing number of workers and total output. All right, so we're just measuring the changes then. So the first worker increases output by 1,200, and then the second worker went 1,200 to 2,200, so they only increase output by 1,000. And then the third worker, 800, 600, and 400 for the last one. Okay, so yeah. So because the workers are having to share a fixed input, they will become less and less productive as you hire more and more workers. So the farmers on the land, you put more workers on the land, but then the amount of land per worker goes down, so they become less productive. Or another example would be if you had a restaurant with a kitchen, and then the building is fixed and the kitchen is fixed, and then all the equipment in the kitchen also would be your fixed inputs. And then if you want to produce more in your restaurant, you can hire more people to work in the kitchen, but as you hire more and more people to work in the kitchen, what happens to their productivity? Yeah, right? Now, I don't know has anyone ever worked in a restaurant before? Probably some of you guys, yeah. Right? It can, workers lose productivity when it gets busy, right? Because they get crowded in there, they're having to share the equipment, they're having to take turns, they bump into each other, they start fighting with each other. Anyway, so yeah, so you can hire more workers, but the productivity goes down. So, okay, so now the curve, now, let's see. So the total product curve goes up at a decreasing rate then, right? Total output goes up, but by a smaller and smaller amount each time when you hire more workers. Now notice on the graphs here that we have labor on the horizontal and quantity on the vertical. These are the only graphs where you have quantity on the vertical. And it's because we're showing the output as a function of the amount of workers. Okay, and then marginal product goes down. And again, if you want to draw a line through a step graph, then you can just draw the line through the midpoint of each one. Okay, so that would be diminishing marginal product. Okay, now why would we talk about this? We talk about this because the costs depend on productivity. If your workers are becoming less and less productive as you hire more and more workers, what's happening to your costs? Your costs are going to go up, right? So we've talked lots about, and especially in Chapter 9, we talked lots about reasons why marginal costs of production will go up. Sorry, this way. So as quantity increases, marginal costs go up. And marginal costs will go up because each time you hire more workers, they're becoming less productive, and less productive means more costly. Okay, so we'll get into that. But then, okay, so then on the next page, though, another reason why we're talking about this is that this is one of the decisions that a business has to make. How many people should we hire? Well, if we hire more people, we'll be able to produce a bit more, but each time we hire an extra person, the extra amount that we're able to produce gets smaller and smaller. And then what are we paying the person, right? So they have to figure out, is it worth it to hire the extra person, right? And how much money will we make from this extra amount of output, and compare that to the cost of the wage for the worker. All right. Okay, so rational people think at the margin. When a producer hires an extra worker, then costs rise by the wages, so they have to pay them. And then they have to compare that to the benefit of hiring the extra worker. And the benefit of hiring the extra worker is the extra amount of output, which is the marginal product. So the marginal product of labor is the extra amount of output they'll get from the extra worker. Okay, so the marginal product of labor diminishes And another way of saying that is that there are diminishing returns to the input. So returns being like reward. So as you hire more and more of the workers, which is the input, there's less and less reward for doing that. You get less and less additional output. Okay, so that will happen when the marginal product of that input falls. Okay, and then this example, I was talking about this, so we could use the kitchen example or this one here. A farmer's output rises by a smaller and smaller amount with each additional worker. That's because they're having to share the same piece of land, and so the amount of land per worker will go down as they hire more workers, and so then productivity goes down. Because, of course, land per worker is important for being productive. Okay, so if a farmer increases workers but not the land, each worker has less land to work with, and so then they will be less productive. So productivity depends on capital, like how much capital per worker do your workers have. If, let's say tractors as well. So let's say for this farmer, the farmer has, say, 2 tractors. Okay, well, if there's only 1 or 2 workers, then they will have a tractor to work with at any time they want to. But then if there's 3 workers and only 2 tractors, or 4 workers and only 2 tractors, then now they're going to have to take turns, and so then they won't always have a tractor to work with, and so then they won't be as productive. All right, increasing production though, and productivity, if that can happen if the farmer got more land or got more tractors. And then, now in these graphs, because the quantity is on the vertical, if the farmer gets more tractors, they'll be increasing production this way. Right? So remember, these are the only 2 graphs where the quantity is on the vertical axis, and so then more output will mean going up instead of to the right. All right, so both of these curves, if the farmer got more tractors or more land or whatever, both of the curves would shift up. Okay, we would think of it as shifting up. Now this one though would be more of a rotation because the origin would still have to be at 0, right? If nobody's working, if nobody's driving the tractors, then nothing can get done. And then marginal product would also move up. Now something else that will increase productivity is, of course, better technology. But you can think of that as fixed in the short run as well, right? Because technology takes time to change. So in the short run, technology is fixed. But if technology improves, then it would have exactly the same effect on the 2 graphs. The 2 graphs would move up because technology will increase production. Good, okay. See. Okay, so now we have exercise 1. And this will be about a food truck. Okay, Jackie runs a food truck business that produces many different flavors of pierogies, which are like dumplings, if anybody doesn't know. Jackie's inputs include 3 trucks, insurance, gas, employees, food, ingredients, cleaning supplies, and serving supplies. Okay. which of the inputs, which of these things would be fixed? The trucks, yep. So the trucks, and what else? Insurance, right? Because it's not something that you pay day to day, right? You just pay it, right? Like a car insurance, right? You just pay it, and then if you don't drive your car today, you still paid it. So insurance would be fixed. So these are things that he would have to pay for whether or not he's actually using the trucks. But then, if he's actually using the trucks and driving them around and making pierogies, then he's going to have to then use all of these other inputs. So all of these other ones would be variable. I'll just put all the others. There's too many to list out. Okay, so all the other ones are going to be variable. All right, so now marginal product of labor. So we've got workers and output, and we're just measuring the extra output from hiring one more worker. Okay, so the first worker increases output by 100, and then it goes to 185, so that's an increase of 85, and then 255, 70, 310, 45, 55, 40, and okay, and then the last worker actually doesn't even increase output at all. Okay, so now we're going to draw the two curves. So we'll put TP on this side, total product, and MPL on this side. Okay, so TP, so for the total product, we just put the amount of output at each point directly above that worker. Approximately, anyway. So it should increase at a decreasing rate. And then for the MPL, we'll show a step graph. All right, we'll stop there. Oh, yeah, yeah. Yeah, well, okay, that's a good question. So the other way to graph it is to just plot these points, but they have to go at the middle. So you could do that, and then you could draw a line through those. That would be fine as well. So you don't have to put those bars if you don't want to, as long as you put these dots in the middle.